Okay, hello again. This chapter is about atomic structure, so let's talk about what an atom is made of. We've said before, and you should know from previous years, previous lessons, that an atom is made up of a nucleus and electrons revolving around the nucleus. Now, the nucleus contains protons, neutrons. The protons are the positive particles, so they have a charge of +1. The neutrons have no charge, so that is a 0. And you should know that the electrons that are revolving around the nucleus are negatively charged. You should also know that anything inside the nucleus is called nucleon. So we have neutrons, which are the neutral particles, the nucleus, which is the central part of the atom, and the nucleons, which are everything inside the nucleus. Now, if we talk about mass, you should realize that an electron has a very, very small mass, a mass of 1/1840, while the proton and neutron have equal masses and they're given a mass of 1. Okay? So let's try this question. This is a sample question. Which statements comparing the properties of electrons, neutrons, and protons are correct? Take a minute, go through them, think which one is right and which one is wrong. So if we say neutrons and protons are both heavier than electrons, is that right or wrong? Do you remember that we said protons and neutrons have a mass of 1 and the electrons have a mass of 1/1840, which is very, very small. So actually the statement that neutrons and protons are both heavier than electrons is correct. Now the other one is only electrons and neutrons are charged. Is that correct? You should remember that neutrons have no charge, so that is not a correct statement. So your answer is B. Okay? Okay. Another sample question. Particles with the smallest mass are which ones? Which? Electrons. The particles with the negative charge, okay, are electrons. The two types of particle in the nucleus of any atom. This question says boron atom, but any atom. The nucleus has what? The nucleus has protons and neutrons. In an atom, there are equal numbers of what? You should realize that in an atom, the number of protons is equal to the number of electrons. Number of protons is equal to number of electrons. So if you look at the periodic table, which we will be talking about in another chapter, you will find that the atom has two numbers. It has an atomic number and a mass number. The atomic number is the smaller one. So if you look at the periodic table and you look at the information about aluminium, you will find that there's a small number. For aluminium, the small number is 13. For the big number is 27. And you should realize that the small number is the atomic number. So if he says, what is atomic number of aluminium? It is 13. And the atomic number is the number of protons. So what is the number of protons in aluminium? 13. The big number is what we refer to as the mass number or the nucleon number. And that is the total number of protons and neutrons in the nucleus. Remember that we said nucleon are protons and neutrons that are present in the nucleus. So the nucleon number or the mass number is the total number of protons and neutrons in the nucleus. So for aluminium, the total number of protons and neutrons is 27. So if we know that we have 13 protons and 27 protons and neutrons, then how do I get the number of neutrons alone? You should realize that it is by subtracting the big number minus the small number. Now, the electrons, we said the electrons is also the small number. So the atomic number is the number of electrons. So for aluminium, for example, the small number was 13, so it has 13 electrons. Now, the word electron configuration means how are these electrons arranged in the atom? We said the electrons, first of all, revolve around the nucleus. And if we have 13 electrons, you should realize that the first energy level, or the first shell around the nucleus, can take only 2. And then the next shells can take up to 8 in our syllabus for now. So the first energy level can take only 2. So you can put only 2 in the first one. Then the next one can take up to 8. That's okay. We still have 3 left, so we're going to put them in the third energy level. So if I say write the electron configuration, you write it as 2, 8, 3. That's how you write the electron configuration. But if he says draw the electron configuration, then you draw it as it is drawn here. The nucleus in the middle, and then the first circle, which is the first energy level, can take only 2 electrons. You can put them as dots, or you can put them as X's. And the second energy level can take up to 8. Usually electrons like to be in 2s, so it's 2, 2, 2, 2. Then the third energy level will take the rest of the electrons that we have. In this case, it is 3. Okay? So far we have said the atom has number of protons equal to number of electrons, and that is equal to the atomic number, and that is the small number in the periodic table. The number of neutrons is then the mass number minus the atomic number. So if you have the 2 numbers from the periodic table, it is the big number minus the small number. That will give you the number of neutrons. Now, what about an ion? What's an ion? An ion is when the atom loses or gains electrons. Remember that an atom has a specific number of protons, a specific number of neutrons, but the electrons, which are supposed to be equal to the number of protons, the atom can lose or gain electrons. So if it loses or gains electrons, it is no longer an atom, it is called an ion. So an atom is the one that has equal numbers of protons and electrons. But an ion has lost or gained electrons. So if it loses electrons, that means, remember that at the beginning it had equal number of protons and electrons. That means equal number of positive and negative charges. But when it loses electrons, that means it has lost some of its negative, and that means it becomes a positively charged ion, and that is called a cation. If it gains electrons, that means now it has extra negative, and that means it is a negatively charged ion, and that is called an anion. Okay, so let's try this together. We have this information from the periodic table, and we want to deduce what's the number of neutrons. And by the way, the word deduce means calculate or find out, because sometimes it's a difficult word to understand for some students. Okay, so if we look at the periodic table, we find that F is fluorine. Fluorine has 2 numbers, 19 and 9. That means the small number is 9, and we said the small number is the atomic number. The big number is 19, and that is the mass number or the nucleon number. Now, if I want to determine the number of neutrons, we said, how do we get number of neutrons? Number of neutrons is the big one minus the small one. So in this case, 19 minus 9, so I have 10 neutrons. How do I get number of protons? We said the number of protons is what? It's the small number, the atomic number. So the atomic number is the number of protons, so we have 9. What about number of electrons? Now this is an atom. How do I know it's an atom? It doesn't have any charge on it. It doesn't have a positive or a negative on it. That means that it's an atom, and that means that the number of protons is equal to the number of electrons. That means I have 9 electrons. Now how do we distribute them? We said the first energy level takes how many? 2, and the next one will be the rest of the 9, which is 7. Okay, what if I say now I have F minus? What does F minus mean? F minus means it is just the same as the one on top with atomic number 9 and mass number 19, but now it has an extra negative charge, and that means it has an extra electron. So the number of neutrons is the same, number of protons is the same, but now I have an extra electron, and that means instead of 9, I have 10 electrons. Now, how do we distribute the 10 electrons? The first energy level takes 2, and I'm left with 8 in the next one. What if I'm talking about aluminium? Now, aluminium has two numbers, 13 and 27, and we said the 13 is the atomic number. The 27 is the mass number. Atomic number is the number of what? Number of protons and number of electrons if there is no charge on it. The 27 is the number of protons and neutrons. Now, how did we get number of neutrons? The big one minus the small one, so I have 14 neutrons. What's the number of protons? The number of protons is the small number. What's the number of electrons? It's still 13. How do we distribute the 13 electrons? We put 2 in the first shell, 8 in the next, and 3 in the last shell. What if I have aluminium 3+? Now, aluminium has the same numbers as the one on top, 13 and 27. But now it has extra 3 positives, or positive 3. That means it has done what? Does it mean that it has gained protons or it has lost electrons? You should remember that we never gain or lose anything except electrons. We only lose or gain electrons. The number of neutrons is the same, number of protons is the same. So I still have 14 protons and 13 neutrons. But now, what is the number of electrons? If it is 3 positives, that means it has lost 3 electrons, and that means now I have 10 electrons, and the 10 are distributed 2 and 8. Do we understand this? You should be able to do that. So let's try this example. The table gives information about 4 particles, A, B, C, and D. Complete the table. The first line has been done for you. So he's giving a certain particle, which I don't know what it is, but if he tells me that the number of protons is 6, remember that the number of protons is ideal for each atom. No two atoms will have the same number of protons. So the number of protons identifies the atom. If I tell you that I have something with 6 protons, you look at the periodic table, you see which one has a small number of 6. Which one? Its small number is 6. You'll find that that is carbon, and that is why he wrote C as the symbol or the formula of the carbon. Now, number of electrons could be C, the same as number of protons, and that means that my C doesn't have any positives or negatives on it. The number of neutrons is 6, and that is why the nucleon number is 12, because the nucleon number is what? Protons plus neutrons. Protons is 6, neutrons is 6, so my nucleon number is 12. So let's try B. B says I have number of protons is 11. Now I would look at the periodic table and see which one has a small number of 11. I will find that it is sodium. So if he tells me that I have number of protons 11, number of electrons 10, number of neutrons 12, what is my nucleon number? We said nucleon number is what? Protons plus neutrons. Protons is 11, neutrons is 12, so my nucleon number is 23. Now, we said the protons is 11, and that means I have Na. But then he says the number of electrons is less than the number of protons by 1. If it were just Na, my proton should be the same as electron. But the electrons are missing 1, and that means that my sodium has an extra positive. Do we understand that? Okay, let's take a look at C. C says my number of protons is 8, and he gives me the symbol as O2 minus. What does O2 minus mean? It means that I added 2 extra electrons. So if I have number of protons 8, then my number of electrons is 2 more than that. So that's 10. My number of neutrons is 8, so my nucleon number is what? We said nucleon number is protons plus neutron. So that is 16. Okay, now in D I have aluminium 3+. So I would look at the periodic table, look what is the small number of aluminium. The small number of aluminium is 13 from the periodic table. That means my number of protons is 13. Okay, so what about number of neutrons? Now, if I look at the periodic table, I will find that the big number for aluminium is 27, but he's telling me that no, the nucleon number is 28. Now, you should realize that this is something that is called an isotope, and we will talk about isotopes in detail in a minute. But for now, we said the nucleon number is actually the total of protons and neutrons. So if my nucleon number is 28, then my number of neutrons must be 15. Do we understand how to do this? Okay, let's try another sample question. Which statement describes positive ions? Take a minute and go through all of them. Positive ions have more electrons than neutrons? No. Positive ions have more protons than neutrons? That's not it. Remember that whether something is positive or negative has to do with the numbers of what? The numbers of electrons and protons. So if something is positive, that means it has more electrons or more protons? If it's positive, then it has more protons than electrons. Okay? Now, this is another one. Let's go through it very quickly. Now, he says I have this particle, which is sodium, and the number of nucleons is 23. So if the number of protons is 11, what is the number of neutrons? The subtraction of that, which is 12, right? Okay, what if I have Cl minus? And he gives me 17 and 37. I'm going to remind you again that sometimes the big number, which is the mass number or the nucleon number, could be different from what you have in the periodic table. So the small number is always the same. For example, sodium will always have a small number of 11 because its atomic number or number of protons does not change. It is always 11. But the mass number could change. Chlorine will always have an atomic number of 17, but its mass number may change. So the mass number that you have here, which he says is 37, is actually different from what you have in the periodic table, but you use what he gives you, not what is in the periodic table. So according to this, what is the number of protons? We said the number of protons is a small number, so the number of protons is 17. What about the number of electrons? We said usually, if it's an atom, the number of electrons should be the same as the number of protons, but that is if it doesn't have any charge on it. Now, this one has a charge of what? -1 means it has an extra electron, and that means instead of 17, it has 18 electrons. What would be the number of nucleons? We said number of nucleons is protons plus neutron. So 17 plus 20, that is 37. Now here he gives me information and he's telling me which element do I have or which atom do I have. Now we said an atom is determined by the number of protons. So if he says number of protons is 26, I go to the periodic table and I look which one has a small number, 26. I will find that it is iron. But actually now the number of electrons is less than the number of protons by 2, and that means that this iron has lost 2 of its electrons, and that means it has a 2 positive or positive 2 on it. Okay? Now, isotopes. There is something called isotopes. Isotopes are what? They're atoms of the same element, having the same number of protons, but different number of neutrons. So, for example, I could have isotopes of hydrogen. Now, hydrogen must have an atomic number of 1. We said atomic number or number of protons identifies the element. So, hydrogen will always have atomic number 1, same number of protons. But the mass number could change. So, the big number could be 1 or 2 or 3. So, these are 3 isotopes of hydrogen. They all have 1 proton, they all have 1 electron, but they differ in the number of neutrons, and these are called isotopes. You have to memorize this definition. Okay, let's try this sample question. Which row describes isotopes of the same element? We said the same element will have what number of the protons? Different or the same? The number of protons should be the same, but the number of neutrons should be different. Do we understand that? So your answer is C. Okay, let's try this one. He gives me two isotopes of iron, one 26 and 54, the other one is 26 and 57. Now, how do these two isotopes differ in their atomic structure? Well, they have different what? They have different number of neutrons. That's the definition of isotopes. Now, determine the number of neutrons present in this isotope. We said, how do we get number of neutrons? We subtract the big number minus the small number. Determine the number of electrons in one Fe3 plus ion. Now, Fe3 plus means that my iron has lost 3 electrons, and that means instead of 26, it now has 23. Okay, another sample question. We have two isotopes of calcium. What is the number of proton, neutron, and electron in each of them? You should realize that the protons are the same. The number of neutrons will be the big number minus the small number, and the number of electrons is the same as the atomic number. Now, determine the number of electrons in one calcium ion. Calcium ion is Ca2+, and that means it has lost 2 of its electrons. So instead of having 20, it now has 18 electrons. Do we understand how to do this? Okay. What is relative atomic mass? You should know this definition as a definition. Average of the mass number of the different isotopes in the ratio of their occurrence in nature. So if I have different isotopes with different mass numbers, then I get the average of that relative to the ratio of their occurrence, and that means that some isotopes, I have a lot of it. So if I have, for example, a sample of chlorine, I could have a lot of one of the isotope more than the other, so relative to their occurrence in nature. Okay, so what are the two types of isotopes? Isotopes can either be radioactive or non-radioactive. If they are radioactive, that means that they are unstable and the nucleus tends to split, emitting radiation. So a radioactive isotope is one that is unstable and its nucleus tends to split, emitting radiation. Now, other isotopes are non-radioactive. Non-radioactive means they are stable isotopes in which the nucleus does not emit radiation. Usually, radioactive isotopes are harmful. So we are not required, or we shouldn't actually expose ourselves to anything that's radioactive. But there are some uses of radioactive isotopes. So you should remember one medical use and one industrial use of radioactive isotopes. The one that I usually say is the medical use is cobalt-60 for cancer treatment. Please mention the isotope and its use. So if he says mention a medical use of a radioactive isotope, I wouldn't just write cancer treatment. I would write cobalt-60 for cancer treatment. An industrial use of a radioactive isotope, uranium-235 to produce energy in nuclear power stations. Remember that the uranium written in the periodic table is uranium-238. But for industrial use here, we're talking about a different isotope, uranium-235, to produce energy in nuclear power stations. So let's try look at this sample question. The diagram shows some properties that substances may have. To which labeled part of the diagram does uranium-235 belong? This kind of diagram, if you're familiar with it, this is called a Venn diagram in math. And we want to see which uses coincide with uranium-235. So, for example, is uranium-235 a compound or an element? You should realize that anything from the periodic table is an element. A compound will usually have 2 or more different atoms, different types of elements. So this is an element, it's not a compound. So my answer should not include actually A or C or B. So the only option that I have is uranium is radioactive and it is used as an energy source. So my answer is D. Which substance does not require oxygen in order to produce energy? Remember that any of these are called fuels, and fuels are things that we burn to release energy, and most of the fuels are things that need oxygen in order to burn. So for example, if I want coal to give us energy, we need to burn it in oxygen. We need to burn hydrogen in oxygen in order to produce energy. We need to burn natural gas in oxygen in order to produce energy, but uranium does not produce energy by burning. So it does not require oxygen. It produces energy by radioactive reactions. So it's a radioactive substance, not something that uses oxygen for burning. Okay, which term is defined by the following statement? The average mass of naturally occurring atoms of an element on a scale where the carbon-12 atom has a mass of exactly 12. Remember, the average mass of naturally occurring atoms, that was definition of relative atomic mass. Okay, so what is the definition of the relative atomic mass? The relative atomic mass was the definition that you have on top there, the average mass of naturally occurring atoms of an element on a scale where carbon-12, remember that all masses of all elements are referred to the mass of a carbon-12 atom. So actually, the relative atomic mass of an element is what? Is the average mass of naturally occurring atoms of an element divided by the mass of one atom of carbon-12 times 12, because it is relative to one atom of carbon-12. Okay? Remember that for definitions. So that's the end of this chapter, and I would expect you to study the chapter from the notes, the PDF notes that are available to you from this course, and try the chapterized questions for this chapter, and then we'll discuss the questions and their answers in the next lesson. Thank you.